Okay, this session is going to be recorded so that you can always revisit at your own time. So it will be stored under topic 5 of the unit. So today's unit is about IPv4 addressing or IP addressing in general. And an IP address is a unique number that we usually assign to a machine to ensure that two machines can communicate together. So when you want to form a network, there's no way you can have two machines communicating, even if they're in the same room and they are connected to devices such as switches and hubs, and the cables have been fixed properly. There is no way the two machines can communicate unless the machines have been configured with what you're going to call an IP address. So in this particular session, I'm just introducing what IP addressing is. I'll later on expect you to be able to do some practical job activity where you are going to have 2 or 3 machines networked together, and you are expected to assign an IP address and see how the two machines are able to see each other on the network. So that I'll guide you on the actual activities that will be undertaking in that small practical. But for now, before we do that, we need to understand what is an IP address, why do we assign IP addresses, what are the different classes of IP addresses, and how do we tell that these two addresses are going to work on maybe 2 or 3 machines in a network, and how do you tell that these two machines can see each other? Because there are some fundamental things that you have to get it right before you say that you are able to configure IP addresses. One of them is to determine whether, if you assign IP addresses to 2 or more machines, you need to be able to tell, are these two machines in the same network or are they in 2 different networks? So that is one of the most common problems that you normally come across, where you have 2 machines assigned IP addresses but they are not able to communicate. They could be in the same room connected to the same networking devices. They could not be in the same network based on what IP address you have assigned to each machine. Now, there are some concepts that we need to get it right. One thing is that when a machine wants to communicate on the network, there are several addressing modes that a machine is going to make use of. One of them is called unicast addressing mode. Unicast means one. So when you talk of a unicast address, it's like saying machine A wants to communicate with machine B. So that kind of communication, that kind of exchange of messages is what we are going to call a unicast addressing mode. Like server A, from the diagram that I've displayed, server A is communicating with maybe server C directly and ignoring the other machines on the network, because maybe that message is destined for one particular machine. From my diagram, you can see that there is this client machine. The client machine is a network of several servers. We have server A, B, and C. But you see this dotted line. First, there is a connectivity device here in the middle. This connectivity device is what you are going to call a switch. Could be a hub or a switch. So a switch is just an intelligent hub. And you can see that from the switch, we have cables running to, there's a cable running to server C. There's another cable running to server A, and another cable running to server B, and finally to the client. Then we have this dotted line, which is just trying to depict the mode of communication taking place currently. That client machine 1 is communicating with server B. So that's why we have that dotted line up to server B. So what this means is that this message coming from client 1 is going directly to server B and not to any other machine. So this is one example of what we are going to call a unicast addressing mode, where one client machine is communicating with another machine in the network directly, and the message is not intended to go to any other machine on the network. So that is what we mean by unicast. Now, the other mode of addressing is called broadcast. And in broadcast addressing mode, we are saying that in broadcast addressing mode, we are saying that the packet is addressed to all hosts in a network segment Now, a host is another term that we use to refer to the devices that have been configured to make use of a network. So if you create a network of 10 machines, you're going to say that you have 10 hosts in that room. So when you mention the word host is any end device that you can have in a network, and then devices will most of the time be computers like desktops, laptops. They could be gadgets like mobile phones, because nowadays in most of the networks or in most of the organizations that we go to, as much as they are going to have a wired network, the local area network, they try as much as possible to ensure that even portable devices can also access the network. And that's where now the concept of Wi-Fi comes in, where people want to access Wi-Fi. And you know that almost 70% of visitors to an organization will access Wi-Fi using their mobile devices. So in that particular case, your mobile device is also a host on that network if it's connected to that particular network. Now, what is a broadcast addressing mode? So in this mode, the packet is addressed to all the hosts in a network segment. So the destination address field contains a special broadcast address. So I want to give an example, like you have one machine with an IP address 192.168.0.1. That is an IP address of one machine, like the client machine in my previous diagram. Now, if this client machine wants to send a message to all the other machines on the network, this client machine will send a message that is called a broadcast message or a packet. Yeah, the message traveling on the network, we're going to call it a packet. So if this client machine wishes to inform all the other machines, or the message is destined to all the other machines, then that kind of message that will be able to go through the switch and come out of the switch to all the other machines is what we are going to call a broadcast message or a broadcast packet. So those names are used interchangeably. So we'll hear packets, message. We are simply referring to the same thing. Now I want to give an example, like in what circumstance would you find one machine sending a message to all the other machines in the network? Now, one very good example is this network where maybe the machines or the host in the network usually get an IP address from the server. So in many organizations, you'll find
You are
there's a
currently
server.
the only person in this conference.
You'll find that there's a server giving machines IP addresses. So that type of server is called a DHCP server, Dynamic Host Configuration Protocol server. So it's a server, it's a type of server that is configured to issue IP addresses to other machines on the network. So now, this client machine uh, could have been offline, and this machine now has been started by the user. And one of the requirements for a machine to be able to communicate on the network is to acquire an IP address. So this machine does not know which of the machines on the network is the DHCP server. So this machine will send what is called a broadcast message. And the broadcast message is usually called, if it's for asking for an IP address, so the type of message that will be sent will be called DHCP discover message. DHCP discover message. And I've said DHCP is a dynamic host configuration protocol. So that is a server that is configured to give other machines an IP address. So this client machine will send a DHCP discover message. So that message will go through the switch to all the other machines on the network. Now, most of the machines will drop the message. The reason is because that message is a DHCP discover message. So the other machines, if the machines are not configured to be DHCP servers, the machines are going to ignore the packet, but they will have received the packet, only that they are going to drop the message. But that particular machine that is configured to be the DHCP server will be able to interpret that this message is meant for me, and it's going to reply with its MAC address and IP address. So if it's able to with its MAC address and IP address, client machine is not able to in that particular. A DHCP server usually replies with a called a DHCP.
You are currently the only person in this conference. You are currently the only person in this conference.